Hi, today I am teaching you how to write the electron configuration of the periodic of elements in the periodic table. When you write electron configuration in the periodic table, you always need to know how many electrons in that element. Electron configuration shows you electron arrangement, how the electrons arranged in the periodic table. So in this chapter, the main thing is how to write the electron configuration. Always you write electron configuration like hydrogen has 1 electron. Hydrogen number of electrons you write as a superscript. 1 means it's 1 s orbital, and then s, it is in s block in the periodic table. So if you look at this periodic table, you know, hydrogen is in it's 1 electron, you write 1s1. Helium, not 2, it's right, helium you write 1s2 because you have 2 electrons. First, like in an atom, electrons arrange in the main shells, right? You know, the principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. You can think these quantum numbers, like if you have the nucleus, around the nucleus you have shells. If I draw it for you to see more carefully, more closely actually, let me see. Okay, so here the nucleus, you can see the nucleus, around the nucleus. Okay, this is the first shell, second shell, third shell. If you look at the periodic table shown in this diagram, here, like this is only the first principal shell. Go here, second principal shell, third principal shell, fourth, fifth. Like period number will give you how many principal shells of that element has. Example, hydrogen is in the period 1, so it has only 1 principal shell. And also n equals 1. And then when you go to the higher levels, like higher principal level, each shell divided into, okay, angular momentum quantum number, magnetic quantum number, like that. So hydrogen, how do you write electron configuration? Hydrogen has 1 electron. This one shows what is the period, what is the principal quantum number. S is the orbital or a subshell that electron reside in, and then 1 is number of electrons. So if I write hydrogen, I would write hydrogen 1 is 1. Always 1 is the principal shell, S is the subshell, 1. Okay, number of electrons. Let me write it again for you. So this 1 is the, can you see the color? Maybe not, darker color. No. Principal shell, I think that's the same, not dark enough. Principal shell, subshells, basically orbital, number of electrons. Okay, so then next element in the periodic table is helium. You write helium, you have 2 electrons, same, 1 is 2, number of electrons. 1 is the same principal shell, so helium is here. Helium 1 s subshell, 2 electrons. Lithium, 3 electrons, right? You write 1s3, no, it's in the second shell, so you have to move to the next one. 1s2, you start 2s1, 3. Lithium, beryllium, 4 electrons, 1 is 2, 2 is 2. S, so they're like subshells. You have subshells, we learn, okay, the S, P, D, and F. S can hold only up to 2 electrons, only 1 orbital. P can hold up, P has 3 P has remember when we talk about angular momentum quantum number, P has L value -1, -0 to +1, so that means you have 3 different shells, so you can have 6 electrons. D has 10, F has 14. So the 6 electron, that means you have 3 small orbitals, so like that. 1, 2, 3. This has 5. 1, 2, 3, 4, 5, like that. 14, it's 7. So now beryllium is good because you have 4. Like you write carbon 5, 1s2, 2s2. Then you go to, okay, it's still in the second shell. You start, okay, second main shell, 2p1. Sorry, it's boron. Boron, it's 2p1. You start carbon 6, 1s2, 2s2, 2p2, like that. So now we have 6 electrons. You count 2, 2, 4. It's 6 number of electrons. Nitrogen, 7 electrons gives 1s2, 2s2, 2p3. Nitrogen. Then you go to the oxygen. Eight, 1s2, 2s2, 2p4. Go to the fluorine, which has 9, 1s2, 2s2, 2p5. Fluorine, we are going to the neon, the last one, which is 10 electrons, 1s2, 2s2, 2p6. So then our second shell is over, right? And then you start the third one. Third shell. What are you expecting? You expect, so this is first period, you expect only 1, second only 2, right? 2s, 2p, and then you go to the third one, 2s, p, and also d. Why d comes? Remember, when you go to the third principal shell, n equals 3, L can be 0, 1, and 2. 0 is S, L, 1 is P, 2 is D. So in third shell you have, when you write the third electron configuration for element in the third period, there's S and PD. So let's write sodium. 11 electrons, 1 is 2, 2 is 2, 2p6, 3 is 1. It goes like that. Okay. So, and at the same time, you can draw the orbital diagram for each. Orbital diagram means this each orbital means one orbital you can represent in a square. Each orbital can hold only up to 2 electrons. In orbital, like see I have drawn here, in orbitals, you show electron in a half arrow up and half arrow down. So this is for the hydrogen, only one orbital, one half arrow, mean only 1 electron. You write for helium up and down, like that, right? And then helium up and down. So why we need to use this orbital diagram? Very important concept comes here, like Pauli's exclusion principle. Like, you know, if you look at helium, what is the principal quantum number? 1. How many? L is 0, so you have only s orbital. Ml is 0. Spin, when you have 2 electrons, because of the spin quantum number, always each electron has its own spin quantum number, so we can differentiate electrons. Each, like up means spin plus half, negative half. So this is the order of electron filling. 1s fills, go to 2s, 2p, 3s, 3p, after 3p, 4s fills, then go to 3d, 4p, 5s. This is the order of filling the electron. You can easily demonstrate, if you can remember. I can show you something. You write okay, 1s, okay, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, like that, 5s, 5p, 5d, 5f. Now how do you write it? So make it like 1s, 2s, like that, and then you write 3p, goes that, 4s, and 3d, like that. So it goes like, sorry, let me choose another color, goes up and then goes down. So now you know 1s first, 2s, 3s, sorry, well, it goes here like that and then comes here, then goes up, come here, look, so it's 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, goes like that. Okay, so those are the main things, how to write the electron configuration in this periodic table. Like this is like they have written, there are two ways you can, instead of writing whole thing, you can write the closest previous electron configuration, closest previous noble gas electron configuration, and the remainings. So calcium, if you write, calcium, if you see it's in the fourth, look at the periodic table, where's the calcium is at. Calcium is in the fourth period, so periodic table you have to write until fourth, 1s2, 2s2, like that. And then you, instead of writing everything, you write closest previous, so 18 electrons gone, argon, brackets, 4s2. That is another way, both ways correct. I accept both ways. And then that's about the main, and also when you write the electron configuration, all the electrons in the outermost shell called valence electrons. Valence electrons, very important. Valence electrons involved in the bonding. Co-electrons, electrons in the inner shells, they don't involve in the bonding. So you need to know the difference in co-electrons and the valence electrons. And then some properties we discuss, like alkali. So we learn already, okay, group 1 alkali metals form +1 cation, group 2 alkali earth metals form +2, and then noble gases, they don't involve in the bonding. So these are some properties, and we saw, okay, these are metals, non-metals, and the metalloids. You need to know the properties of the metals, non-metals, and the metalloids. And then this is important, metals always form cation, non-metals form anion, right? And then metals always form cation, non-metals form anion. And then some periodic properties we discuss, atomic radii. When you go across the periodic table, atomic radius decreases. When you go down, atomic radius increases. And then always keep in mind, cations are smaller, then goes to the neutral atom, and then anions are bigger. And magnetic properties, paramagnetic, you call paramagnetic if you have unpaired electrons attracted to the magnetic field. When you write the orbital diagram, you see there's an unpaired electron, that is paramagnetic. Diamagnetic, when you write the electron configuration, all electrons paired, it's diamagnetic. And then ion sizes, ionization energy, these things are important as well. Okay, thank you.